And then in this window here, you're going to click on Create Project, like we did last time. And once you've clicked Create, you're going to choose where to save it. So you go Desktop, and you go Honours 2018. And I created a folder, a new folder here. And you can just call it Bushveld 3D. Because before we were working on the Bushveld, it was in 2D. So now we're going to do 3D. So just create a folder that we can save all of this stuff inside. Okay, and then give the file name at the bottom here. Again, I would say Bushveld 3D and put your name. Bushveld 3D and then your name. The nice thing about Kingdom is that you can actually have one Bushveld 3D, and inside of that, different people can like work on different things. So we click Create, User OK, Auto SQL. It's just where it's saving the data, and it should start creating the project. Okay. So again, this project is in meters. Most of the times it's in meters. It's an American software, that's why it's got the option of feet. This seismic datum elevation, if you remember before, this is taking into account the topography. It was recorded and it was 500 meters. So you can put in 500. And then just click on the OK button at the bottom. And you can leave the increments at 200. Metric, sorry, yeah, metric. When you click OK, it says changing the project map unit recreates lat longs for all wells. You must close and reopen project before changes take place. Are you sure you want to make these changes? Yes. We haven't actually loaded anything in this project, so it doesn't make a difference. Next window says, do you want to use a coordinate system from an existing project? Say no. We're just going to do it all from scratch. Okay, and then again, like last time, the window comes up and you're going to go to Africa, and you're going to go scroll down to South Africa, and again, you're just lucky that I know the coordinate system for this these data. But for now, we'll go back and look at the data so you can understand why we're choosing it. But we're going to choose Hardebeeshoek, which is LO27. Now, Hardebeeshoek, instead of Cape, tells us it's quite new data. They collected this data in 2000, whereas if they collected it before 1999, you would have used Cape. And LO27 is just because I fiddled around in Geosoft and figured out what zone it was. But usually the Bushveld complex, when we used to do field school there, we would use LO27. So it's the zone in that area. So click on LO27 and click OK. Okay, and it just takes a bit of time to load up. Okay, so at this point now, let's actually, before we load the data, because we're going to have to know which columns the X and Y values are on, let's actually look what our data looks like. So everybody open for me size C. So you can search at the bottom, it's SEISEE. It's free software. It's just nice for viewing the SegY file data. So size C, open it up. Okay, and now we're going to open up the SegY file that we're going to load into Kingdom. So everyone click on File and Open. And then navigate to where you saved the file I gave you on the flash drive. Yeah, so the first one is, it says 3D final process volume blah 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 dot .sgy, which stands for SegY. And you can click on it and click Open, or just double click. Okay, and so these first are your traces, and how you would display them better, but it's not worth the time because we're really not looking at them there. But if you ever wanted to, you would change these values here, which are labeled as gain W, gain C. Let's try 0.01. Yeah, you can spend ages playing around trying to get them. There's a bit better. Okay, so change your gain here to put 3 zeros and a 1. Everybody go here and click on trace header. That's what we used it for the other day. And this I find it is one of the easiest, quickest ways to view what's going on in your headers of your SegY files. And so you can see, everybody click for me over here on this arrow. There's a blue arrow here on the top left. And what it will do is it will put arrows on all the columns. And so it's literally listed all the columns here. And so the first column is the trace number. Everybody can take off the tick next to trace number. In this row here, it says from bytes 1 to 4 is trace number. Take it off so it goes away. Next one says trace sequence number. FFID is at byte 9 to 12. You can take that off. Byte 13 to 16, trace number with field. And then byte 17 to 20, it says shot point. And so that's obviously a useful number for us to use. And the next one down, 21 to 24, says CDP. And then 25 to 28 says trace number. Now, I actually looked at this data beforehand, and Kingdom picks up that shot point column is actually your inlines, which I'll explain now. And this second column, what was the word? Trace number, is actually your cross line, or it could be the other way around. And so what happens in a 3D survey is you've got obviously lines going that way, and you've got lines going that way, and at 90 degrees to each other, and one will be called an inline, and one will be called a cross line. Okay, so these values we are going to use when we load the data into Kingdom, because then it knows what numbers are associated with those lines. Okay, and then you can take off all the ticks down to 73. So I know you could do this automatically, but just tick by yourself, take off all the ticks down to byte 73. From 25, is it? 29 to 72. So keep 73 on. Okay, everybody got it? So what you should have now is you've got, I think it's your shot points associated with inline, shot points associated with the cross line. Then it says source X, source Y, CDP X, CDP Y. And you can see from the values here for the Ys, there's a minus 2,800,000 value for the Y values. You can scroll along if you need to. And that is why I'm telling you that it's in LO27. Remember the other day, LO27 had this minus 28 million. Okay, so it's always good to just go here and look what's in your different headings. Okay, so close this down. You can just minimize it and go back to your Kingdom suite. And everybody click for me on the tab at the top that says Surveys. And then go to Import Segwa. And this is where we went the other day to import the 2D data. Which one did we click on? Does anyone remember to import the 2D data? Yes, with coordinates, because we took the coordinates from the file headers. So today, we can only, because we're dealing with 3D data, click on the first one or the last one. So we're going to just click on the first one for now, because it's 2D or 3D. But the problem here is it doesn't import traces with options to create survey and load coordinates. It doesn't automatically load the coordinates. We'll have to do that ourselves. Click Next. Top button is where it says Create 2D Survey. Click there and change it to Create 3D Survey. And further down, Browse. And you're going to look for that SegY file that you just opened in size C. So it should be on the desktop in Honours 2018. Okay, so make sure size C is closed, or else it will moan at you because the data is already loaded. This data is in the time domain, not in depth, and click Next. You want to get your data in time, because if it's in depth, it means somebody else has converted it to depth, and you can't always trust what they've done. So click Next. Again, we've got amplitude data, not any of the attributes, so click Next. The first button now is different from last time. It says inline/crossline number in trace headers. Autofill, survey geometry, full SegY, file scan. So this is saying it will automatically look in the SegY headers to find the inline and cross lines, which is nice, but if your file headers are not set up properly, then it might cause a problem. Okay, click Next. And this is similar to what we saw last time. It's actually telling you where exactly it's going to look for the different data. So the first line there is going to be your file name. And then it says the inline starts in byte 17. And if you remember from size C, that was where our shot points were in byte 17. Next one down, it says cross line starts in 25. It was the second column along. And then it tells us there that X coordinates are starting in byte 73 and 77. It might seem trivial, but if they're not in the right columns, you've got to go there and figure out which columns they're in. And I didn't have any idea about these columns beforehand, so I didn't know how to load them. So it's to just give you just an introduction to the different numbers. So click next at the bottom, and you can see it's going to load the stuff in. Scanning segwire file to get survey geometry information. Okay, so everyone give the survey a name. I'm going to call it Bushveld 3D. Ideally, you should know the mine where this was conducted, but I think the data is very mildly confidential, so that's why we're not going to type in the name of the mine. So just type in Bushveld 3D, and you can see under here for inline and crossline, it's picked up values from the headers. The inline runs from 1296 to 1951, and the crossline runs from 1247 to 2234, and the bin spacing is 1. So you can click next. It says world coordinates must be loaded before your survey can be displayed on the map. Do you wish to load the world coordinates now? Click on yes. Okay. Okay, so it has figured it out for you from the heading what the different coordinates should be. So it's telling you your inline values on the left, crossline values, and what are the x and y coordinates for the intercept of those points, those two values. So click next. That doesn't look good. To view and select your world coordinates. Okay, we might have to come and redo this. I did it differently when I practiced the project. It should give us a square because our survey is a rectangle, and it's giving us these weird points. So it's literally in this slide trying to define the corners of the square. So this might not work, but let's click next and see. We can always reload them. Select a solution by clicking on the appropriate button. Okay, so it's picking up the problem. Okay. So this definitely is not working. So the red, to view and select your world coordinate solution, press next. Okay, so everybody go with me, go back, and actually click cancel at the bottom. So see, this is where problems start. So it's not picking up the right coordinates in the headers. It's picking up the right columns, but it's not able to define the corners of the survey area. So we're going to click cancel to input world coordinates, and we're going to do it a different way just now. So just click cancel. And click next, and it jumps over the fact that we're loading coordinates. Okay, and then here, this is all the stuff that Ray spoke about last time. Sample interval, number of input, samples per trace, etc. So leave this all the same. You can click next. And then this last slide is where it's going to load all the data. Click finished. And you can see now it says it's loading in line 1,400 or 1,900, so now we just wait. Okay, well, while it's busy loading, let me explain what I did. So I literally took the coordinates and determined the corners of my square, and that's what we're going to load in now. So you can see here, wait, I think they just need 3 corners of the rectangle because they can work it out. So this is the inline, crossline, x and y value of the different corners. If we plot them, we can see what it looks like. Insert. Okay, so Kingdom wasn't picking up the exact corners, so I've defined them, and that's what we're going to give input into Kingdom now. So has everyone worked? Yay, okay. So you should get this message saying seismic data loaded for the Bushveld. Traces loaded. How many do you have? I've got 506,000. And so obviously if you had 0 there, you would be worried and you would double check what's wrong. And so everyone click OK. And nothing changes on your base map, but if you go here, if you go here on the left here to surveys and double click, it should open up and you'll see the the survey. Okay, so it says the name there on the left-hand side if you double-click on surveys. But it told us it's not going to show us anything on the base map because we haven't told it what the extents of our survey are. So everybody go back with me here to surveys, go import world coordinates. So it sounds fancy, but that seems to be kingdom or seismic talk for just import the coordinates of your survey area. And the only option you can click on is the last one, 3D by dialog. Okay, and you select a survey, is the Bushveld one. Oh, sorry, I haven't loaded mine. Just so click on world coordinates. It loads in your inline and crossline and your X and Y coordinates. Click next. And you can see it's, like I said, it's picking up the corners of the rectangle. I'm not sure why it's drawn the rectangle here and not extended it down. But it's picked up. I think the problem is there is a larger survey that I clipped. So it won't cause problems, don't worry. But the main point here is that you need the coordinates of the survey area. Click finished. And now you finally displayed on your map. You've got a map. Okay. One last thing to do before we start looking at the actual seismic data is let's load in the magnetics. So the magnetics in the data we used on Wednesday or Tuesday was quite boring. This is very interesting magnetics. So everyone click on for me on culture and go import. And remember we imported a culture group. Okay, and here I think it's a TIFF. So you're just going to have to change the file type to TIFF and open and give it a name. I just call it Aeromag. And click OK, and it loads in the background. So you can see that Aeromag covers the whole area, but our survey is a small part in the top right. So does anybody want to guess what this feature going from west to east is? West to east, this one going here. Fault, yeah. It's mapped on surface as being a fault. But after speaking to Sue and looking at the regional, like the whole area of magnetics, it's a swarm of dikes. So it could be that the dikes went along a fault. So we don't often see dikes on seismics because they're vertical, but sometimes if they go along faults, we'll see the offset in layers because of the faults. Okay, and this blue feature here going northwest to southeast, this, what do you think that is? Dikes, yeah. This strong pink anomaly on the eastern side is the upper zone of the Bushveld complex, and that's where there's magnetite. So it's a magnetic gabbro, so that's why it's very strong magnetic susceptibility. And then these smaller anomalies here, they're most likely due to something called IRUPs. So IRUP, does anyone know? IRUP, so it stands for iron, hence the fact that they're often magnetic, rich, ultramafic. So ultramafic just means it's got a lot more of the magnesium iron in it. And pegmatoid, as far as I know, just means usually the crystals are quite big, so it's had time to cool. And so I showed the picture of it. These are the chromite seams in the Bushveld. These bodies can come up here and break through it, and sometimes go along it, and then they come up here and they can go up, and they can do whatever you can imagine. I think when I was in undergrad, I kind of thought they were this pipe coming up that nobody really ever explained to us that they are any shape and they just destroy the reef. And they often either are positively magnetized or negatively magnetized. I've even heard sometimes they're not even magnetized, so they seem to be a disaster. And so you can see quite a few of them down here, a lot going on up here, so this area must be quite difficult to mine. Does everybody want to open a seismic line and let's see what that fault dark zone looks like on the seismics? Make it red, then right click on it and you get options, and go to the first option there that says display inline 905. 9? The first one. Oh, it doesn't. Oh, it's fine. Whatever yours is, just click on it. Click on the first headline. Okay, and you get your seismic section. That's fine, don't panic. If yours is black or white, don't worry. Make your window smaller and just move it to the side so you can have your seismic section and your map next to each other. Okay, and so you can see, as we saw before, Kingdom shows you which line you're looking by showing this strong red line, and it says the window you've currently opened is only showing this small blue area. So you can see if on your seismic window you scroll left to right, that blue block moves up and down the line. You can see I don't have any data in this top area here, but as I move towards the south, I've got data. Okay, something you can do on your map is go put your mouse on top of that red line and drag it towards the bottom part of the map to where we actually want it to look. So I literally clicked on it up here and dragged it down to over this fault zone. Okay, so now everybody's job is to tell me where on their seismic section the fault zone is. Yeah, the tip is that it's not easy to see. You would think it would be this huge feature, but maybe it's because it's vertical. So the other thing to keep in mind that with magnetics, the fault zone will be at the join between the positive magnetic anomaly and the negative. It's not going to be over the positive or over the negative. So maybe the easier thing to do is to pick a strong horizon, and then it's easier to see if it's displaced or not. Okay, so everybody, let's go to this window that you're in there, make it big, and zoom, and then push this 4 squares, corners of the squares button, and it'll give you the whole section on that screw. Okay, feel free to go change the color bar. I think I'm going to change mine to red, or your choice. You can. Why don't we all click the blue arrows on the side until you find a color bar that you like? And there are a lot of them. That's one of Kingdom's good things, is it's got lots of color bars. So this, click on that blue arrow on the right hand side. Okay, so keep going until you find a color bar that you feel displays your data well. Are you guys sticking with? Okay, I think I'm also going to stick. So I like the ready one. Everybody said they can't really see what's going on with the fault. I'm going to just zoom out again. Oh wait, not zoom out. I'm going to just put these side by side. Okay, so I just wanted to show you here. There's a very strong reflector here coming through. So mine's at about between 0.4 and 0.5. Does everyone else have a strong reflector around 0.4, 0.5? So that's called the UG2. I have boreholes, but for the life of me, I couldn't figure out how to import them, even though I've done it before. So can you see in the top part of the study area where this blue block is, it's pretty flat. There's a bit of a bump there. Maybe there's 2 faults there. It would be interesting to see. So we're up here. Now I'm going to move this square to the south, over this fault. Okay, so let's see, where exactly is this fault? So the fault is over here, and it's coming, or the dark, and it's coming through over here. So the interesting thing here is that you've got the UG2 actually doming up here, and you can probably see it better on your data. This lower data is looking a lot like what we saw on that other seismic line. There's this dome in the basement, or what else was the other name for it? Diapir. So there seems to be something else going on down here. You would think it's actually the fault, but if you put your mouse on top of where the maximum area is, the maximum uplift, it's actually a bit south of the fault. So it seems to be something else. Maybe they are related, but it's not the same structure. So there seems to be some sort of diapir down here. Let's pick the UG2. Okay, so everybody go. How did we create a horizon last time? Yes, horizon management. I'd say call it UG2. Give it a name that's a color that's different from whatever color bar you've chosen. I'm going to choose green. Then click OK. And then what do we do next? Set active surface for picking. Great, you're just double checking that it is selected. Cool. And now H. Cool. We can. Okay. So how about everybody try pick the UG2 on your horizon. So the UG2 is formed, the strong reflector is formed by alternating layers of pyroxenites and north this out, and north this out, and chrome out. So those alternating layers give you the strong reflector. Okay, and then last thing I thought to show you is actually we haven't looked at how to work with inline and cross lines. The fact that we're not just picking in 2D. Cross line. I'm going to click it. I'm going to drag my cross line down to over this fault zone. So you can see it's showing me that I've got 2 lines open. I've got 2 red lines. And let's look at where they intersect. And so I'm going to drag my mouse along to where they're on top of each other. So make sure on your inline and your cross line you've dragged along to where they overlap with each other. And I'm going to put them side by side. So you can see on my base map I've got overlapping blue squares. So I know that I'm in the same area. Okay, and then put your inline and your cross line next to each other so that you can see them side by side. Okay, so this red line tells you exactly where they overlap with each other. So this red line here on this left-hand side, there we are. So this red line over here is this line coming in and out of the board, and this red line here is this one coming in and out of the board. And so that's what you've got to worry about in 3D, is that you've got to make sure that if you pick your horizon over here, you've got to make sure that you're picking the exact same horizon on this side. So let's go back to our 2D hunt and we'll look at that. Something else I just wanted to point out quickly. This dome looks wonderful on this inline, but this cross line, everything's kind of dipping in this direction. And that's because the dip of the bushveld complex is towards, let me show you, everything here is dipping in that direction. So this line here, even though there's a dome here, a lot of what you're seeing anyway is the dip of the bushveld complex in that direction. That's why the dome doesn't look that interesting. Whereas this line here is kind of a long stripe, and that's why you're seeing these features. That's why the UG2 looks quite flat along this dome, and you're picking up, quite flat along the section, and you're picking up this dome. So everybody, I want you to use that 2D hunt. Okay, we're going to have to start from scratch because a lot of us deleted the UG2. Go and delete your UG2. Create a new horizon that's UG2. Use that 2D hunt. I want you to pick the UG2 on this line, and then look on your cross line. It will actually show up as a circle of where exactly you've picked, and you can use that to guide where you pick on the cross line. So if you haven't already, please delete your hunt. So you do that by going to this column here, double click on horizons, and make sure that whatever's in there is deleted. And now let's create a new horizon. So horizon management, UG2, pick a new color, and go horizon, set active horizon for picking, okay. And then on your screen, right click and make sure you've done picking type, 2D hunt. So once you've picked your horizon on the left-hand side here, if you zoom in on this cross line, exactly where this red line is on the left, I've got the green horizon going across. This only works if your horizon goes across the red line. When I look on the red line on this side, it's hard to see here, but I've got a green dot. And so that's telling me over here is exactly that point on the cross line. And so then I would go to this cross line and click here and try continue it. You can see this cross line is not as easy to see. So you can see mine has clicked up here and gone that way. This 2D hunt method is most difficult to use when you have more steeply dipping reflectors. It doesn't always pick it up well, but I would say mine should actually continue down here. So I'm just guiding it where it should go down. If I just keep clicking further along, it kind of guides it down. This has guided it too much. if you get to this point here, you can see I've got my green over here, I've got my green over here, but it's forcing it to go down here. You're going to have to use a different picking method to force it to go up. So picking type, you can also do manual, linear fit. You literally draw a line as far as I know. So everybody, why don't you go with me, right click and go to picking type, go to manual and go to linear fit. The other option is spline fit, and you can zoom into your area and you can draw a straight line where you want it to pick. So you can see in my area here, I haven't done a very good job here, but I wanted to carry on across here and join up this section. So I'm going to click on that linear, and then I can click along here. It's a lot more intensive, but I'm clicking where I want it to go, and I want it to end here. And if I double click, it forces it up to go along that line. So I should probably correct this section here. There's obviously something going on here. It's either poor resolution or it's a fault coming through. But for now, I'm just doing a general picking of where I want it to go. Okay, and so you can see, that's why I say pick zoomed out, so you get the general trend, and then zoom in, and then you need to pick up about faults. As you can see here, it's going up along this horizon, so maybe there's a fault there and I need to pick a fault. Let's zoom in. We can view these in 3D. Okay, so this region here has got a lot of positive small anomalies, so we think, lots of IROPs in this area. Everyone go to your sections that you've got open, right click on the sections, and then the top, second thing from the top says display current line in view pack. Yeah, click on it. Okay, see if mine loads. Okay, and so like I said, it can take a bit of time. Okay, if it's done the one, go to your other line, the cross line, and say also open in view pack. It should open in the same window. Can anybody figure out how to do a horizontal time slice? So I just want to show you, because you've got a mouse and you've got a touchpad. If you click on the top right-hand corner here on the hand, you can rotate it, whichever direction you want. The home button takes you back to the original view. And these different buttons at the bottom here, I should be doing it here. These different buttons at the bottom will expand it in the X direction, will expand it in the Y direction and the Z direction. You can also rotate. My buttons on the top right hand side, you can literally rotate it around the Z axis, these ones over here, and it will spin for you. So you can sit and look at it and try to pick up features. Anybody figure out how to do a horizontal slice? If you right click on the screen and go here to display time slice, second one along, it will give you a horizontal line. Did it work? Loading time slice. Due to the number of colors. Okay. So it's loaded on my map. Okay, and it's loaded it. If you go back to view pack, it's loaded it in view pack. So there's actually a time slice. I meant to say to zoom in, you just use your scroll button. Everybody needs to work out. Dominant frequency, we said. Dominant wavelength, and we'll use that to work out the dominant wavelength. We said the velocities here, we said the bushveld was around 6,000 meters per second. So can you give me, what is the depth, how deep are we seeing on the section? The section goes down to 1.5. How deep are we viewing? Okay, you don't have to use the values on the screen, but just mark on the screen, like where did you measure from, and like what did you do, peak to peak?
Peak to peak.
That's fine. Ray suggested for next time do zero crossing to zero crossing. So that's between the peak and the trough to between the next peak and the trough. But yours is fine for now. Okay, so just draw on the picture peak where peak is for us. So did you draw in the middle? Like here. Did you just go from there to down there? Okay, perfect. I forgot to say, sorry, did everyone notice that down here it gives you what the time, if you hover your mouse, you can use it next time, if you hover your mouse on top it gives you the time down here. Yeah, it's not the best either.
That's 0.54 minus 4.2.
Okay.
And my period was 0.02 seconds. And frequency is equal to 1 over period, which is equal to 1 over 0.02, which gives me 50 hertz.
Does everyone agree? Sounds good.
Then from the dominant frequency, I calculated the dominant wavelength, which is equal to velocity over frequency. And the velocity, I used the velocity of 6,000 meters per second, which is 6,000 over per second. That's per second passes the per second.
Oh, I like how you do your units. Good job.
120 meters for dominant wavelength. And from dominant wavelength, I calculated the depth to the dominant wavelength. So the depth is velocity times time, but the time I'm looking at, they are in the two-way travel time, so divided by 2. So take the velocity, which is 6 kilometers per second, times the time, which is, since I said 3.5, then divided by seconds, 0.5 divided by 2 seconds, cancel seconds. Then I get something close to approximately 1.5 kilometers. Measure. You all got this, right? Something close to that. When did you get the depth to the dominant reflector?
It depends what depth you did the dominant reflector at.
Yes. And
Okay, yeah.
the
Do
vertical resolution is wavelength over 4. Then my wavelength from here was 120. That gives me 30 meters. So we can see things that have thickness of about 30 meters.
Okay, or potholes or faults that have a throw of about 30 meters.